Okay, so today class you will going to learn about the entire topic of the first unit, basic of networks. So we go ahead on the revision of the basic of networks. Okay, so it include further than these five major area. One is basic terminology. In that basic terminology you will going to learn about the basic things such as a network. What is the definition of the network? Circuit, what is the current, voltage, energy, power. So these are the basic terminology in followed by that one. Okay, types of the elements. Types of the element, it will go to classify network element, active element, passive element, time variant, time invariant, unilateral, bilateral elements. Okay, so lumped circuit, distributed circuit. So like the element is classified, everything is coming under the terminology. And further you will go to series connection, parallel connection of that one, or element, L element and C elements. Everything it is included for the terminology. So next one is the Kirchhoff law. So Kirchhoff law, it will going to basically classify into the two types. One is a current law, second one is a voltage law. You will going to learn. Then analysis, it consists of that one node analysis, super node, mesh, super mesh, and the electrical sources. Okay, major sources a voltage source and current source. That source is either the dependent source or independent source or practical source or ideal source. That one you will going to learn in the types. Then source of the transformation technique. Why do I want to transfer the technique? Because for simplifying my circuit I need to simplify. How do I want to simplify? I need to convert a voltage source into the current source or current source into the voltage source. Any one method I will going to transfer to simplify. Then next one is the concept of the duality. So duality means just reverse. Okay, that is a duality. Okay, duality means just reverse. Reverse means open circuit means closed circuit means open circuit, voltage source means current source means voltage source. Like about that is called a duality. Dual network. In the dual network, it consists of the two things. One is what is that one? First one, it include for the okay, mathematical equation based you will going to solve. Second one is a graphical method used to you can solve very simplest one. Then last one more topic is called graph, concept of the graph. So in that one, okay, incident matrix you will going to derive, or another one is a tie set matrix, cut set matrix. That's all. So this is a total topic behind in the basic of network in the unit. So let's we go ahead and to see all that one by one detailed. Okay, so we're going to see one by one in detailed. Okay, detail of that basic terminology, followed by Kirchhoff's law and analysis, electrical source, concept of the duality and dual network, and concept of the graph in this class. Okay, first one. So what is network? So network means what is the next one is the circuit. So interconnection of that two or more simple circuits. So this is a network. What is the next one? Circuit. I will going to tell you. So network means what is that one? Interconnection of the two or more simple circuit elements. Simple circuit element. Okay, element means resistance, inductance, capacitance. Okay, interconnections. So interconnection of two or more simple circuit element is called a network. The network may be excuse me. The network may be open circuit or closed loop network. Any one, okay, it is applicable. But a circuit, when you have go for that one, means the network, the first topic. Okay, the network contain at least any one of the closed loop. So the circuit is nothing but the network. Okay, contain at least any one of the closed path. Okay, any one of closed path. Then only it is called as a circuit. The next one is a current. Flow of the electron in the conductor, flow of the electron in the conductor, or flow of the charges in the conductors. You can say about that current. So flow of the charges in your conductors. Another one is what is equation? Current is equal to charges to time period. Charges to time period. So ratio of the charges to time, you can say. The next one is a voltage. Voltage means potential difference between the 2 points. Potential difference between the 2 points occurs means that is called a voltage. So one more that one equation is what is that one? You can say work done to charges. Work done to charges. You can ratio of the work done to charges. You can say energy. So I have the energy. Morning I have the very active energy. So what is that one? Capacity for doing the work. So I will going to do the capacity of the work doing. That is called energy. Yes. So the energy it will going to store in the different form: mechanical energy, electrical energy, chemical energy, like the energy stored, capacity for doing the work. So next one is a power, almost similar to that energy. What is that one? So power, I have morning. If my energy is high in morning, so my output power is more. My energy is low in afternoon, my okay output power is less. So what is a power? Power is nothing but the ratio of the energy to, okay, energy to the time period. So the ratio of the energy to time is called power. Okay, the next one. So that's all about that. This is a basic terminology. In addition, with some more basic terminologies there, that basic terminologies are it is included for elements. What are the elements? Means resistance, inductance, and capacitance. This is the element about that one. It is act as a load on that circuit. Also, it is act as the load. So what is the resistance? Resistance means just oppose the flow of the electrons, the flow of the current. Okay, it will come to normally oppose the flow of the charges. Okay, current. So that is that one. Ohm's law, V is equal to I into R. From the Ohm's law, always you can keep it. I means what is that one? V by R. R means what is that one? V by I. Okay, this is the unit of the resistance is called ohm. Okay, inverse of the resistance. What is called the inverse of resistance? One more question. That is called conductance. So opposite. Okay, 1 by resistance is equal to mho. You can say about mho. It is denoted letter is a G. G is a denoting letter for the conductance. What is a power equation? Power, general power equation, P is equal to VI. P is equal to VI. Then here, okay, as per that one resistance. So resistance in that one, what is that one? V. So I and R. Substitute into the I into R in the place of the V. Then you will going to get that I squared R. And this is called okay, power equation of the resistance. Then next one of the next two more parameters, that is called inductance. Another one is capacitance. That is nothing but ammeter, voltmeter, meter, voltmeter. How do you connect the ammeter in the circuit? Always connect the series with the load or a series with the circuits. Okay, how do you connect the voltmeter in the circuit? There's a voltmeter is connected across or parallel to that element, parallel to the load. You can, that is the method you will going to connect the capacitors. Okay, so what is this one? Power rating of Li square. Okay, of 1 by 2 of Li squared means of CV squared. Just this I say about that one. It is a current. This is about the voltage. So of Li squared of CV squared. So just it is opposite. Okay, here is a V is equal to L dot di by dt means this is a it is a seriously connected, it is a parallelly connected. So of V means what you will go to, just you can write about the I is equal to C dot dV by dt. Okay, where do I have written? Yes, this is the equation about that I, just opposite. Okay, then next one. So V equation is written. What about I equations? I equations, where is that one? So here I don't write it about that I equations. Okay, I will show you next slide. Okay, so once V equation is there, then substitute into the power by equation P is equal to V into I. In the place you will go to substitute, you will going to get that about that power equation of the capacitor. Okay, so this is about that I equation. What about the I equation of the inductance? I equation is equal to 1 by L integration V dot dt. So what about here capacitance? I place is a replace into the V, and V place is a replace into the I. Same integration. L is a replace into the C. Just okay, opposite, because it's a series connection. This is a parallel connections. Okay, this is ammeter. This is a voltmeter. Ammeter is a closed circuit. Voltmeter is a not closed circuit. Voltmeter is a should not be closed. So the short circuit should not be happen. That's why ammeter and voltmeter should not be interchanged. So if you are interchanged about that one, what will happen? So ammeter place you will going to interchange into the voltmeter. The circuit never spoil. Okay, why? Because the voltmeter is a open place. Okay, so circuit never spoil. The current is not flow. So circuit is not working. That's all. But voltmeter place, if you are replaced into the ammeter, voltmeter place replaced into the ammeter, the circuit it will going to get the affected. It will going to spoil the circuit. It will going to short circuited. Be careful. Okay, that's why it's both also opposite. So network elements, when you will going to see about the network element, means active element, passive element. So what is active element? Teacher, active element, passive element, students. What teacher is doing? Giving the sources, giving the information, giving the knowledge. That's why it is called voltage source, current source. Passive element, resistance, inductance, capacitance. That is about the passive element. The next one types is a unilateral, bilateral. Unilateral means I said about that one. Okay, unidirection. That means multiplex D-mod. Okay, D-mod, it is a entry D-mod, super Reliance mod. That are the okay. Multiplex of that mod. Entry is one door, exit is another door. So that is a unidirectional. That is called unidirectional. Bidirectional means normal shop, you will go to enter and exit, or it is the same door. That is called the resistance, inductance, capacitance. Then linear circuit means, okay, voltage. So what is a linear circuit? Like it is increasing. So okay, voltage with respect to time period. So linearly it will going to increase. That is called a linear circuit. Non-linear circuit means it will go to variations. Okay, up and downs. So lumped circuit, RLC, distributed circuit means a distributed transformer, time variant, AC by AC, time invariant, DC. So this is about that one, network elements. Okay, next one is a network detection techniques. When you have go ahead on that network detection technique, you should be know familiarly series circuit and parallel circuit of the equations. So circuit may be connected in the series method. Okay, either R, L, C. Another one is a parallel method. You will going to connect it. I already said these two is just opposite. So inductance is the opposite for the capacitance. I already said. Okay, coming to that one, these two, okay, resistance and inductance is similar. If the circuit, okay, is connected, it's if the element is connected in seriously, if it is connected seriously connected means R equivalent is equal to 1 plus 2 plus 3. So this is similar for R as similar to that L. Okay, then next one, if the circuit is connected in parallel, if it is a parallel means 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. Okay, if it is a number of the distances connected in parallel, it is similar to that one inductance. It is similar to that one. It is a 1 by R equivalent. So I need for the R equivalent. Be careful. So you will going to find out the equation 1 by R equivalent answer. If answer is x, if answer is x, if it is means what is the R equivalent? So R equivalent 1 by x, 1 by x, 1 by x. We okay, keep it in your mind. So R equivalent is 1 by x. Okay, so if it is completed, okay, this equation is going to the series method, this equation is coming to the parallel method of the capacitance. That's all. So this is about the series circuit and the parallel circuit of the elements is used. Okay, two resistance are connected in parallel. If it is means R equivalent, product dot by addition, R1 into R2 dot by R1 plus R2. Okay, this is a rule. This is a formula. Okay, fine. The next one is we're going to see about the current division rule and the voltage division rule. What is the current division rule? Okay, easiest method to we want to find out the across this one. So three resistance are connected in series. I need across the voltage across this points. So here is a voltage is a 10 voltage I will going to apply. So here is a V1, V2 and V3. So 10 it is equal to 10. Okay, supplying 10 it is equal to V1 plus V2 plus V3, V1 plus V2 plus V3. Then if you are going to substitute the Ohm's law, okay, if I have know about that one, what is that one common? I. Okay, I is a common. Then I, because that one it's a series circuits. Then I into R1 plus I into R2 plus I into R3. These are the lengthiest method. So then R value is given, R1, R2, R3 value is given. Okay, then I value you need to find out first. Then after find out the I value, you can substitute here. I value you can substitute. So in this place, you can keep it only VR3. Then you will going to find out the V3. Then you will going to find out the V3. Our simplest method, what is that one? Use that voltage division rule. What is that one? You need across the V3. Yes, write down the V3. V3 is equal to, what is the input voltage? V. Formula. What is that one? V. So V is a 10 voltage. Multiply. So this R3. Yes, this is R3. Then R3, you will go and write the resistance value. R3 divided by. Okay, how many is that there? 1, 2, 3 resistance are there. Then you will go to add 1 R1 plus R2 plus R3. You will going to add. So 3 resistance. That's all. This is the formula. So this is a formula. So coming to that one, current division rule. Current division rule means, so you see here. So here 3 is coming. Suppose here is a, I need to find out to for that one. Okay, I2. So I2 is equal to same formula. I2 is equal to I multiply, but resistance is the opposite resistance. R1 divided by R1 plus R2. So this is the formula for that one. Is the direct ready-made formula is given. Use the formula. You will going to use it. Okay, for two resistance are only given the formula. Connected in parallel. Then furthermore about the basic terminology, let's we going to see branch. What is the branch? So the element is these are the branch. These are the branch about that ones. Okay, these are the branch. So how do the branch is connected between A and B? So A and B. What is that? A. This is called a node. What is a node? More than okay, more than one. I mean two branches are connected. Two branches are connected means that is called a node. Two branches are connected. Yes. Two branches are connected, 2 and above. So 2 and above branches are connected, node. It is a name, it is denoted as a node. Okay. The next one terminology, junction. Junction means 3 roads and above, 3 roads. So 3 roads and above, that is called a junction. So junction is, this is junction you can say, this is the junction you can say. Okay. The next one, yeah, node. So node means A, B, C, D, E. Yeah, all the point is node. Why? Okay, two branch elements are connected. Okay, so a point, two or more elements join. Yes. The next one is a maze and a loop. So what is that one? It's a closed loop path. Closed loop path of the circuit. Okay, this is one closed loop path. This is also one closed loop path. This is about the maze you can say, or another name you can say about the loop. The next one, open circuit and short circuit. What is the difference between open circuit and short circuit? Open circuit means current is not flow. So current values is equal to 0. So current is inversely proportional to the R. So what is R value? R value is infinity. This is a open circuit diagram. Okay, if it is a short circuited means across closed circuit. If it is short circuit means the current value is a maximum value. Maximum means it's called infinity. Ideal condition I'm going to speak. What about the resistance value? Resistance value is 0. Why resistance value is 0? Ohm's law, V is equal to I into R. Ohm's law, I is equal to R. I need I only. So if you are going to keep it, I is equal to V by R. V by R. So is it inversely proportional or not? If it is I values increase, what about the R value? Decrease. So I values decrease into the 0. What about the R value? It is increase maximum, or it is called infinity. The next one, simple node. The node means what is that one? Two or more element is joined. That is called a simple node. Okay. The next one, principal node. What is a principal node? That is junction. Junction is nothing but a principal node. Junction is nothing but a principal node. Okay. So interconnection of at least 3 elements. That's all. Then next we will go on to see about the analysis. There is a 4 analysis important in the unit. One is a node analysis, second one is a mesh analysis, super node and a super mesh. That's all. So node analysis, node, Kirchhoff current law plus Ohm's law. So Kirchhoff current law plus Ohm's law, that is called the node analysis. What is the mesh analysis? They will ask you. So Kirchhoff voltage law plus Ohm's law. That's all. This is a you will going to always keep in your mind. Okay. So current law, Ohm's law, voltage law plus Ohm's law. That's all very simple to you will going to remember. Next one is a super node. Super node. Okay. What is a super node means? Node it is denoted. Here is a what is a node. So already we are discussed what is a node. A node is a point, 2 or more element joined. Okay. Node. This is called a point. So node. Okay. So here is A and B is a node. Okay, between the two nodes, okay, voltage sources are present. See that one in your given circuit, between the two nodes, if it is a voltage sources are present, means then you can say this is about the circuit is a super node circuit. The circuit is a super node. Between the two nodes, voltage sources are present, then you can say it's a super node. Then you will go and write the V2. Okay, here is a plus sign is connected to that 2 terminal. V2 minus V1. It is equal to the 3. You can write about that one equations. Then what is the next super mesh? You can see loop. Okay, but okay, here is one loop. Here is another loop. So okay, so intersecting. This is a word you can say intersecting the current source. Okay, between the two loops. Okay, between the two loops, intersecting the current loop. Is it intersect or not? Yes, it is intersecting. So then only you can say about the super mesh. Then only you can say about that super mesh. You can say. Then how to write the equations? Where is my directions? My direction is upward direction. If my direction is upward, my direction means who is comer? So here is a comer. So that one I will go to write, give the first priority. So if it is I2 means I will go to give that I2 first, then followed by another loop minus I1. Then what is my current value? If it is a 5 means 5, it is equal to 5. That's all. So this is about the equation number 1. Similarly here, what is that one? V2, I said V2 minus, why V2? Because plus is coming to that 2 terminal. V2 minus V1, it is equal to, what is that one here, value 3. So this is about the equation number 1. Okay, equation number 1 is over. Then what is the step number 2? Remove the voltage source. If you're going to remove the voltage source, then connect the short circuited, even close the circuit. If it is a step number 2, in that point, okay, remove the current source, it is make it as an open circuit. Current source is a open circuit. That's all. So we will see, okay, network reduction technique. After that we will going to see about that these are the analysis. So network detection technique we will going to go ahead. What is this one? So these two resistances connected in the series, make it as a single one. These three is connected in parallel, 3, then make it as a single one. After make it as a single one, okay, these two is connected in the series, make it as a single one. After that one, these two is connected in parallel, make it as a single one. After that one, these two is connected in series. So that's all. This is step by step. You will going to do it on that once. Okay, step by step. Okay, see, I have make it as in 3 is three resistances converted into single resistance. 2 is connected into the single resistance, and after that what I will going to do? So these two, okay, these two is I will going to replace into the single. Okay, yes, and after that what I will do? These two is replaced into the single. Okay, and already what is this one is there? Then these two is connected in series. So make it as a single one. So now flow of the current is I. Then I is equal to Ohm's law, V by R. Then voltage division rule is to, you will going to find out that one very carefully you can do. So here is a 10 voltage. So 10 voltage is a V1. This is a V1 terminal. This is a V2 terminal. See that one, V1 terminal, V2 terminal. So be careful because it's a series. This is one part and this is another part. Okay, so voltage it will going to divided, V is equal to V1 plus V2 only. Then this V2 first you will going to find out. After find out the V2, then this V2 value is a common for these two resistance. Okay, these two resistance. Then you can going to use the voltage division rule used to directly you will going to use it. Okay, here is a what is that one? V2 value. First I will going to find the V2 value. After find the V2 value, voltage division rule, V value multiply 11 ohm divided by summation of these two. Okay, similarly current. Okay, I need to find out the current of that one. So use the current division rule. Okay, used to directly you will going to find out the current. Okay, so I current is no. Then after that multiply with this one divided by summations. So you will going to see, if you are not getting on details, see my previous video. So Kirchhoff's law. So what Kirchhoff's law is saying? Kirchhoff's law, it has the current law and then voltage law. Kirchhoff current law and the voltage law. What Kirchhoff current law is going to say? It is both also almost similar. What is that one? Kirchhoff current. So summation of current, it is equal to 0. What is the voltage law? Summation of voltage, it is equal to 0. That's all. This is about Kirchhoff current law and this is about Kirchhoff voltage law. Kirchhoff current law and Kirchhoff voltage law. Summation of the current is equal to 0, or another term you can say incoming current is equal to outgoing current. Incoming current is equal to outgoing current. Okay, in the circuit, incoming current. Who's that one? I1, I3. So I1 and I3 is a plus sign and this two is outgoing current minus sign. Okay, so see that it written. Otherwise, incoming current you can write it on one side, outgoing current you can write it on the another side. Okay. Then next one, Kirchhoff voltage law. What is the Kirchhoff voltage law? Summation of V. V is equal to 0. So what is summation? Algebraic summation of voltage is equal to 0. Or another word you can use, the potential rise is equal to, so rise equal to potential drop. What is the potential rise? It's a 10 voltage I will going to give. So what is that one? V1 is it V1 plus V2. So 10 is equal to V1 plus V2. That's all. 10 is equal to input source, that is called potential rise. It is equal to potential drop, V1 plus V2. That's all. That is called a potential drop. So V1, how do you write? I into R on Ohm's law. You will going to write. Okay. So this is as usual simplest problem. Okay, this is a current source is given. Okay, here is a node A, B, C is given. Okay, then you will going to find out what is the point at node A. So what at node A, what is that one? So here at node A means 10 amps is coming up to the here. It will going to further, it will going to divide it. So 10 it is equal to 5A plus I4. Yes. Then from that one 5, 10. So I4 you can kind of find out. Similarly at the point of the B, what is that one? So incoming, who is the incomer? So 5A incomer, and 5A it is equal to I3 plus 2A. Is it written or not? Yes. So then you will going to find out the I3. Then at the point of the C, so who is the incomer? So I4 is incomer. I4 plus I3 it is equal to I5. Yes. Then you will go to I5, you will going to find out. Okay. So it is a current source based. If it is a voltage source means 10 voltage it is equal to VR1 plus VR2 plus VR3. You will going to write. It is equal to. So voltage rise equal to voltage drop. Otherwise you can coming to the one term minus 10 you can write. Minus 10 you can write. Then if it is a value is given, yes, 4 voltage is given, 2 voltage is given, then this is a value they didn't given. So you can find out, that's all. Simple. So Kirchhoff's law, so mesh method. Okay, okay, you will go to write your assumption, your own assumption. You will go to write. Okay, from that one you are entering into that okay source on the minus terminal. So minus terminal you will go to enter means minus 50. Otherwise you can keep the 50 on the one side. Then I into okay I1 into 15 plus 1 into I1 opposite minus plus 5 volt. So like about the loop 1, loop 2, loop 3 you can create and use the calculator directly. You will going to find out of the I1, I2 and I3. Otherwise use the theoretically I1 it is equal to delta 1 divided by delta. You will going to find out I2 is equal to delta 2, I2 is equal to delta 2 divided by delta. Similarly I3 is equal to delta 3. So delta 3 divided by delta. Okay. So method you will going to do it. Okay. And after that they will going to ask you what is the current is flowing on that one. So I1 value you can find out. Okay. Flow of the 10 ohm. Okay. What is the voltage across? So like they will going to ask you. So what is the current is a flow on this point? This point is a two current. One is in and one is out. So I1 minus I2. Then you will going to use to find. Okay, node analysis. It's a very simple. So Kirchhoff current law plus Ohm's law. Okay, coming to the point. What's step number 1? What you want to do? Very simplest method. Okay, where is the node? ABA, BB is given. Okay, assume the all the current move outward directions. Okay, I will going to assume. Okay, that's all. After assume, then you will going to write it. Okay, what you want to write? So one okay VA divided by source is there. If a VA divided by source, which is source? If it is that one okay VA VA minus source. But here is a arrow mark of the supply arrow mark of the source is opposite. So minus 12 in bracket minus 12. Okay, whole divided by okay this is a I is equal to V divided by R. So V value I have written. Then R value, what is R value? 5. Then write the 5. Simplify VA plus 12 divided by 5. I have written. Then VA divided by 30, VA minus VB divided by 15. That's all. So then write it on VA in separate and VB in separate, and then constant terms you will go and write this separate. Okay. So this is equation number 1. Similarly, VB point, you will go and write about the VB point. So now that one, 2 equation you will going to get. Then solve that one as usual. You use the calculator. You can solve that one. Otherwise, use the theoretically solve it. So if it is a plus sign, minus sign, cancel. Then find out the VB, and after that you can substitute into the first equation. Then find out the VA. That's all. If you will going to see your answer. If your answer is both is a plus sign means you are assume the direction is correct. If it is your answer is getting minus means simply you can write my assumed direction was reverse. That's all over. My assumed direction is a reverse. Then you will go and write. Okay. So when write about the answers. Then further VBA they are asking, and then 30 ohm resistance they will asking. Okay, 30 ohm resistance, what is that current flow? So then I is equal to VA divided by 30. So VA value you have found, okay, 9 point plus 9.65, then divided by 30, you will going to get the current value. Similarly, VA minus VB, substitute to subtract 2, you will going to get the answer VBA. Okay, so it's everything is a simple. See, is it the normal node or the super node? Normal node or super node? Between the two node sources are present, my source would be voltage source. If it is a voltage source, then only you can say the super node. Is it voltage source or current source? It's a current source, so it is not a super node. So normal node only you will going to use. Think about that one, normal nodes. So current value, so 6. My assumed direction, this is also flowing same direction, so plus 6, that's all. Here fix plus 6, you can move opposite side. Yeah, yes, I have written here plus 6. Okay, so summary. Okay, mesh analysis as similar to that Kirchhoff voltage law. Assume your own directions, assume it and write that one. Okay, equation number 1 2 3, I1 I2 I3, you will go to write. Okay, as similar to that Kirchhoff voltage law, no changes. Okay, then super node. Okay, what is a super node? Between the two nodes voltage sources are present. Yes or no? Yes, voltage sources are present. Okay, how it is a present? Plus symbol where it is connected. Plus symbol is connected to the V2. So V2 minus V1, okay, it is equal to 12. Plus symbol only we will going to look. So first, okay, equation is ready. Then remove this voltage source, make it as a closed circuit. Once closed circuit, here 1000 also there, no use. Leave it. So once short circuited means shorted, that's all. Then as usual for that one, Kirchhoff the node analysis, Kirchhoff the current law plus Ohm's law. Then V1 values and V2 values, write only one equation you will want to write. That's all. Equation 2 you can get. Solve it, then V1 bit. The next one, super mesh. See there, intersecting the two loop current sources are intersected. Yes, it is intersected. If it is intersected, okay, then it is a decided, it's a current loop. Okay, who is the arrow mark? Arrow mark is downward. Either I1 is going downward or I3 is going downward. I1 is going downward, so I1 minus, giving the priority to I1 first, because he is the follower. So I1 minus I3, it is equal to 10. That's all. This is the first equation. And after that one, remove. So make it as an open circuit. So this 10 and this 2 also open. So remove it. That's all. Then you will going to get this circuit. Here how many loop? Closed loop. This is one closed loop. Write the equations. Here is another one closed loop. Only one closed loop, but 2 is belongs to the I1. This 2 is belongs to I3. This 8 is belongs to the I3. Okay. Then write the equations. 1, 2, 3 equations. Then you are going to get I1, I2, I3 over. Electrical source. So sources in that one. So due to the time limited, I will go a little bit fast. Okay, sources. Generally, it's classify independent sources and independent sources and dependent sources. Dependent sources is nothing but a controlled sources. Controlled sources means, okay, say the symbol is right, like this is a diamond shape of that one. They will going to give the symbols. Okay, the independent sources are classified into two types. One is ideal source and again one is a practical source. What is meaning ideal? Ideal means yoga condition. I am sitting on the yoga. So yoga means my energy is a high 100%. Then practical means that is I'm presently talking, walking, speaking. Like that is a practical. Okay. General I already said voltage source, current sources are there. Then write the here V, then I, V, I. You can classify practical voltage source, practical current source. Where is that one? This is about the practical voltage source, practical current source. Okay, ideal voltage source. This is ideal voltage source, ideal current source. So see what is the difference? Ideal condition, no resistance are connected. Okay, seriously and parallelly. So practically, okay, resistance are connected in series with respect to the voltage. Okay, parallel with respect to the current. Yes, it is connected due to the resistance. Okay, you will going to get the drop. But here constant. Here constant, ideal 100% I said, but a practical it's a draw. Okay, so this is about the classifications, okay, and diagrams. And then similarly you can come to that controlled sources, or another name is called dependent sources, voltage and current. So voltage control current source, voltage control voltage source. So like voltage control, current control. Okay, so here is a I V. So like you will go and write alphabetic order I V you can write. Okay, what is that one example? FET analysis, op-amp, BJT, no device. Yeah, this is already we were discussed about that one. Okay, resistance are connected in that one. Okay, seriously in the voltage source, resistance are connected in parallel to the current source. Okay, so conversion from the coming to this point. Okay, conversion, what is this one? Voltage source connected series with the resistance, what is the ohm? 4 ohm. So I want to convert it into the current source. Okay, so current source means current and then parallel resistance. You will go to draw the diagram. What is the resistance value? The same resistance value you can take. These two ohms are the equal, these two are the equal. Okay, then I need the current value. So Ohm's law, what is saying? V by R. Substitute the V value, divided by R value, then get the I value, substitute it, that's all over. So based on that one, you will go to solve the any type of the problem. Just only you need for that conscious. So how to you will going to connect it? See, the 2 volt is connected to going to here as well as here. Simplify. So already we were discussed. So similarly here is a current source. So how the current is going? So current is going connected to here as well as the here. Okay, so like you will going to simplify. So next one is a duality. What is a duality? Just reverse. All of you stand up. So what you want to do? Sit down. All of you sit down. Just opposite. Stand up. Open circuit means closed circuit. Switch on means switch off. Voltage means current. L means C. R means conductance. So just you will go to reverse. Voltage source means current source. Just opposite. What is a dual network? So network you will going to form the network and write that once. Okay, circuit you want to draw. Okay, conversion circuits. So either two method, either you can go for the mathematical method or graphical method is very simplest one. Only simple steps. So method is used to do. Okay, but whenever you can go for the graphical method, use the tabulations. Use the tabulation. What is the tabulation? This is a tabulation. What is a path? Another one is what is a volt element, what is a dual. Okay, the path, okay, and then dual based you will going to draw the circuits. First we will going to form the tabulations. Okay, from the, after form the tabulations, so column number 1 and column number 3 used to you will going to complete the circuits. You will going to complete the circuits. Okay, it is the easiest one. Okay, so what is a graphical method? Okay, so loop inside A, B, number of the loops is there, you can give the inside that one A. Okay, outside is a N is there. N to A, how do you connect? N to A, element number 1, element number 2, through these two elements. N to B, how do you connect it? Through that, this element. A to B, how do you connect it? Through this element. You like, you will go and write. After write, just opposite element you can write. Then after write, so column number 1 and column number 3, take 2, you will go to draw the circuit. So this is about that graphical method, very simplest one. Next one, mathematical method. Mathematical method means Kirchhoff voltage law. Used to you will go and write the equations. Use the after write the equations. So what are the dual terms? You will go and write. Substitute the dual terms. After substitute the dual term, draw the diagrams. So that's why it's a very simplest one, graphical method. Then last one of that one topic, very simplest topic, graphs. You will going to draw the graph. So when you want to draw the graph, this one you will going to keep in your mind. So voltage source means closed circuit, current source means open circuit, either L or C or LC, everything it is a dash lines, straight lines, connect line, closed lines. So any sources are there in the circuit? No, elements only there. R it is equal to L, L it is equal to C, everything is an element. Everything you will going to make it as a straight line. That's all. That's all. So from here to here, I will going to join. Over. What is this one? If this is a voltage source. If it is a voltage source, okay. I can connect it. Suppose it is a current source. What do you want to do? Don't connect. That's all. This line don't connect. Excuse me. Okay. So this is about the graph. First step. You will going to draw the graph. The next one is a tree. What is a tree? So rules is important. Okay. Join all the nodes. Okay. I will going to join all the nodes. 1, 2, 3, 4. I will going to join. No closed loop. Don't make the closed loop. So you have possibilities 1 or possibilities 2, 3, 4, 5 possibilities. Take any one of the possibilities. This is called a tree. If you know these two, then you can go ahead on that one. Classification, incident matrix, tie set matrix, cut set matrix. 3 things you will going to implement. Okay. So what is that one? We'll going to see through that one of the problems. Okay. First one in the problems. Okay, graph. Circuit is given, so convert into the graph. So voltage source is there, so straight line, then 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 straight line. So graph is ready. Then next one, okay, arrow mark. Does the arrow mark is given their problem? Yes, if it is given, then use the arrow mark. Follow the arrow mark. Don't change the arrow mark. Don't change it to the arrow mark. Follow the arrow mark. Okay. Then node name is given. Yes, they are given. No, they didn't given. Then you can give the name. So you can give any one place. How many nodes? 1, 2, 3, 4. You can give the name A, B, C, D or 1, 2, 3, anything. So your base. So A, B, C, D. You can give. So then branch name, branch number is given in that one. Do they given? No. Then you can give 1, 2, 3, 4. Like you will going to give. So these are the steps you can complete. After complete, come to the incident matrix. Incident matrix. What is that one? So x-axis, y-axis, like. So nodes versus the branch. How many branch? How many lines? 6 lines. How many nodes? A, B, C, D. 4. Yes. Okay. What is the rules I said? Oh, my head. In my head is a problem is coming to my head. So what I said? Minus. Problem is coming to my mind. It's a minus. Problem is going away. In my mind, I will going to give the plus. I will going to give the plus. So no problem. I will cool, neutral. So that's all. So A. In the A, who is a comer? Problem is comer is a 1. Give the minus. 2 and 3 going away. Give the plus. See here, I got given or not. Similarly B. Who is a problem? Comer. Problem creator is a 5. Give the minus. 6 and 1 is they are moving away. So give the plus to the 1 and 6. 1 and 6. Like you will go to incident matrix complete. Next one is a tie set matrix. When do you go for the tie set matrix? First you want to draw the tree diagram. Draw the tree diagram. What is the tree diagram is saying? So tree diagram means join all the nodes. Join all the nodes. Don't make the closed loop. That is a tree diagram. Yes, I have joined that one all the nodes. I don't make the closed loop. Okay, what are the lines? Remaining lines are there. So that all the line is use the dotted line. Dotted line is to you will go to close. Dotted line is to you will go to close. The dotted line is a links. That is dotted line is called a links. That is called a tie set. Okay, that is called a tie set. 1 tie set. What is the number? 3 is a tie set. 5 is a tie set. 1, 3, 5. As usual, 6 numbers you can give. What is my arrow? Arrow denoted in the dotted line. Dotted line is based on that one. You will going to give the current flow. Dotted line is a arrow. Dotted line arrow based. You can give the current flow. If it is the same direction, give the plus. Opposite direction minus. You can give. That's all. Very simple. Same direction plus. Opposite direction minus. No one is coming 0. That's all. Very simple. Then next one is a cut set matrix. Cut set. So you can see the thick line, that is called a twink. Twinkle twinkle little star. So twink, in that one twink you can say in that twink. Okay, so maximum one twink, multiple number of the links. Okay, my twink is my directions. My twink is going inside, so you can cut inside. My twink is going inside, cut inside. My twink is going inside, cut inside. You can cut. So who is that one? Same direction, my twink directions. So he is a follower. Yes, one is a follower. Give that one plus. It's the opposite. Give the minus. So who is a follower? 4 and 5 is, and this is a minus. And here, so 2 is a 2 and 3 is a follower, and again is a minus. That's all. So form the matrix. Matrix once you form, that's all. The problem is over. So yeah, this is a method. And one more topic is remaining in that one, that is called the dot connection and coupling coefficient. What is the dot connection and coupling coefficients? See, already you have studied about that one. This is a transformer you have studied. Okay, transformer. Okay, in the transformer there is two winding. Okay, L1 and L2 winding. This is a between that. What is that means? Core is there. So core is there. When you will going to give the power supply to that one winding, automatically flux are induced. When you will going to give the power supply to one winding, automatically flux are induced. How it is induced? Means through the core it is induced. Through the core it is induced. Power is induced. Power is induced on that is secondary of the transformers. How? That is a mutual inductance. That is called a mutual inductance. That's all. What is self inductance? So remove this once. Okay. So you will going to give the power supply to that one coil. Here is a flux is induced. That is called a self inductance. That is called a self inductance. So what is the denoted letter? L is equal to N pi divided by I. What is the mutual inductance? M is directly proportional to the N pi by I. This is about the mutual inductance. Okay, simple to say. Two houses are the nearby. You may seen about that situation in the film. The children's they are okay. 10th class student, they are two members studying in the same school. Okay, same class. Their parents are very close. The two members' house is very close. Okay, in the street. Okay, one student start to study on the early morning 5 o'clock. Automatically, another student house, the bulb it will going to turn on the 5 o'clock. That's called mutual inductance. Flux. Okay, so coming to that one, if it is there both also, okay, good mood to study, that is called a mutual inductance is a plus sign. I mean current enter to the both in the dotted line. Current enter to the, if I have see the transformer, small size of the transformer also, that is a dot line is mentioned. What is a dot line? Means entering the point. Okay, so this is a entering on the point. This is also entering on that one. So both current are entering on the dotted line, means that is called adding. Either this point or I have dotted line here. So my source is coming here, no problem. So both also ended that one. Okay, current on that one. So current is both coils flow out of the dot lines. Yes, that is also add. See that one. Do I have added the plus M or not? Yes, I have added the mutual inductance on the plus. So what is in that left hand side? Left hand side is a V. It is equal to flow of the current in the resistance plus this L1 dot di1 by dt plus M mutual inductance. I have write mutual inductance of that I2. This is also you can write. Suppose one is a dot line, another is a ending on the dot line. What will go? It is a opposing, subtracting. Okay, so V1 is a enter. Okay, V1 is a current is a leaves on the dot line. V2 is enter on the dot line, means here is a mutual inductance is opposing on the one. Okay, so you can do the subtract. So opposing the polarity. So subtract. That's all. This is about that dot rules. This is called a dot connections. Then coupling coefficient is nothing but this is a formula. K is equal to M divided by capital M divided by root of M1 into M2. What is M1? The ratio of that one actual ratio of the actual mutual inductance divided by maximum value of the mutual inductance. So this is that one. Okay, this is about the coupling coefficients. So this is a point I will going to stop. So about that your first unit total things is over.